Hello friends, welcome to my channel Eccentric Learning. In the last video, I have explained about the concept of averages, how to find average of a group of numbers using assumed average method, and we have also discussed about the weighted average concept. So I hope you have gone through that video. If not, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to learn about the concept of mixtures, and we'll be also doing some word problems based on this concept. And in the next video, we are going to learn about the rules of alligation. So let us start with today's video. When two or more qualities of things are mixed, then the resultant is called a mixture. For example, say if I have two varieties of rice, say R1 and R2. Say the first variety of rice R1 consists of 30 kg of rice at rupees say 40 per kg, and the second variety of rice R2 consists of say 20 kgs of rice and at rupees say 50 per kg. So when these two varieties of rice are mixed, then the resultant is called a mixture, and I can find the average price per kg of rice of this resultant mixture simply by using the concept of weighted average, which we have already discussed in the last video. So if I want to find the average price per kg of rice, so this would be simply P1 Q1 plus P2 Q2 upon Q1 plus Q2. So this would be 40 times of 30 plus 50 times of 20 upon the total quantity, that would be 30 plus 20. So if you calculate this would be 1200 plus 1000 upon 50. So this would be 2200 upon 50, and that is 44. So that means when these two varieties of rice R1 and R2 are mixed, we are getting a resultant mixture in which the average price per kg of rice is rupees 44. A mixture can also be a solution, that is, one liquid is mixed with another liquid, then the resultant is also called a solution. For example, say if I have 40 liters of milk and it has been mixed with say 10 liters of water, then the resultant is also called a solution. Now, whenever we come across the word solution, we also come across a word concentration. So let us try to see what is concentration of a solution. Now, if we take this particular example, that is when 40 liters milk has been mixed with 10 liters water, we have a 50 liter solution. So concentration of the solution is simply can be termed as the proportion or the percentage of the liquid in the total solution. For example, in this particular case, I have the 50 liter solution, but the quantity of milk is 40 liters. So the concentration of this solution would be simply 40 liters upon 50 liters, which would be nothing but 4 by 5 or 80%. So that means out of every 5 liters of the solution, we have 4 liters of milk, or we can say that the concentration of the solution is simply 80%. In a similar way, say if I have 60 liters of pure alcohol and say it has been mixed with say 20 liters of water, then the concentration of the solution would be simply 60 upon the total, that is 80, which is nothing but 3 by 4 or 75%. So that means out of every 4 liters of the solution, we have 3 liters of alcohol, or the concentration of the solution is 75%. So in this way, we can find the concentration of the solution. Okay, so now let us see some formulas which we'll be using whenever we solve the questions of mixtures. Suppose if I have a container which contains 100 liters pure milk. So what I'm doing is I'm taking out 10 liters of this pure milk and I'm replacing this with 10 liters of water. So after this first operation, the quantity of milk left in this container would be simply 100 minus 10, that would be 90 liters, and the quantity of water would be simply 10 liters. So after the first operation, the quantity of milk and water would be simply 90 and 10, or we can say that the ratio of milk and water would be simply 9:1. Now say if I repeat this operation once again, that is, I'm taking out 10 liters of this solution now, and I'm replacing this with 10 liters water. Now, when I'm repeating this operation, the quantity of milk and water won't be 80 and 20, because in this case, it is a solution now. So when I'm taking out 10 liters of the solution, milk and water would be taken out in the ratio of 9:1. So the quantity of milk left in this container would be simply 90 minus 9 by 9 plus 1, that is 10 of 10 liters, as I'm withdrawing 10 liters of the solution. So this would be 90 minus 9, that would be 81 liters. And in a similar way, I can say that the quantity of water left in the vessel would be simply 10 minus 1 by 9 plus 1, that is 10 of 10, and plus 10 because I'm adding 10 liters water to it. So this would be 10 minus 1 plus 10, that would be 90 liters. So after the second operation, the quantity of milk would be 81 liters and the quantity of water would be 90 liters. Now, if I repeat this operation for the third time, in a similar way, I'll be getting the quantity of milk would be 72.9 liters and the quantity of water would be 27.1 liters. Now, we can find the quantity of milk and water till n operation in a similar way, but every time we can see that the calculation will be a bit lengthier. So we have a direct formula by which we can find the quantity of milk in this solution after n operation. So let us try to see that formula. So this is the formula which we can use directly. That is, the quantity of liquid left in the vessel or in the container after n operation is given by x into 1 minus y by x to the power n, where x is the initial quantity of liquid in the vessel and y is the amount of liquid that is being replaced. But say if this y, that is the quantity of liquid which is being replaced, is different. That is, in the first case, I'm taking out say y1 liters and I'm replacing with water. And in the second case, I'm replacing with y2 liters of water. And in the third case, I'm replacing with y3 liters of water and so on. In that case, the quantity of liquid left in the vessel would be simply x into 1 minus y1 upon x times of 1 minus y2 upon x times of 1 minus y3 upon x and so on. So we can use this formula and we can check whether we are getting the same values or not. So if I apply this formula to this particular problem, in that case, the value of x would be 100 and the value of y is 10, since we are replacing the same quantity every time. So if I want to check after the third operation, so this would be 1 minus 10 upon 100 to the power 3. So if you calculate this, this would be 100 times of 9 upon 10 cube, which is 9 times of 9 times of 9 upon 10 times of 10 times of 10. So if you calculate this, this would be 72.9, which we can see is exactly the same quantity which we have calculated earlier. So simply by using this formula, I can directly get the quantity of the liquid after n operation. And the quantity of water can be simply found out by subtracting this 72.9 by the total initial quantity. Now, there can be one variation to this part, that is, in the beginning, there was not pure milk in the container, rather milk and water were in the ratio of 9:1, and again I'm taking the total quantity to be 100 liters. In such case, the amount of liquid left in the vessel which is not being added after n operation would be given by x dash into 1 minus y upon x to the power n, where x dash is the initial quantity of liquid in the vessel which is not added, x is the total quantity, and y is the amount of liquid being replaced. If this y is different, in that case, the formula would be simply x dash into 1 minus y1 upon x into 1 minus y2 upon x and so on, just like we have seen in this case. Now, if the same process is repeated 3 times, I want to find what is the amount of milk left in the vessel. That means I'm taking out 10 liters of the solution and I'm replacing it with 10 liters of water. If I repeat this process 3 times, then what would be the amount of milk left in the vessel? So we can directly use this formula. So after 3 operations, the amount of milk left in the vessel would be simply x dash into 1 minus y by x to the power n. So here x dash would be the initial quantity of milk in the vessel, which is 9 by 10 of 100 liters, that is 90 times of 1 minus y. Y is the quantity that is being replaced. So here the value of y would be 10 upon the total quantity in the vessel. So that was 100 to the power 3, since I'm using this operation 3 times. So if you calculate this, this would be 90 times of 9 by 10 cube, that is 9 times of 9 times of 9 upon 10 times of 10 times of 10. So if you calculate this, this would be 65.61 liters. So in such kind of cases where initially there was not pure liquid in the vessel, but in some ratios, we can directly use this formula. So these are the two formulas in addition to the weighted average formula that we need to keep in mind while doing the sums of mixtures. So now let us see some questions based on the concepts we have learned. Okay, so let us start with this question. If 20 liters of 30% milk solution is mixed with 30 liters of 20% milk solution, then find the concentration of milk in the resulting solution. So that means we need to find the percentage of milk in the resulting solution. So in such kind of cases, we can directly use the concept of weighted average. So the concentration of milk can be simply written as 20 times of 30% concentrated solution plus 30 times of 20% concentrated solution upon the total quantity, which would be 20 plus 30. So if you calculate this, this would be 24%. So that means when 20 liters of 30% concentrated solution is mixed with 30 liters of 20% concentrated solution, then the concentration of milk in the resulting solution is 24%. Okay, so now let us say this question. A vessel contains 100 liters of pure alcohol. 20 liters was taken out and replaced with water. How many times should this procedure be followed such that the concentration drop below 50%? So we have 100 liters of pure alcohol and we are taking out 20 liters every time. So how many times this process has to be repeated so that the concentration will be below 50%? That means the quantity of pure alcohol in the solution would be below 50 liters. We have one formula for calculating the quantity of liquid left in the vessel after an operation, and that is given by x into 1 minus y by x to the power n, where x is the initial quantity of liquid in the vessel and y is the quantity that is being replaced. So if we simply use the values, this would be 100 times of 1 minus 20 upon 100 to the power n. So if we simplify this, this would be 100 times of 1 minus 20 upon 100. So that would be 80 upon 100, that is 0.8 times of n. Now, if we choose the value of n to be 1, in that case, the quantity of pure alcohol in the solution would be simply 100 into 0.8, that would be 80 liters. In a similar way, if you check for n equals to 2, that would be 64 liters. Now, if we check for n equals to 3, in that case, this would be 100 times of 0.8 raised to power 3. So if you calculate this, this would be 51.2 liters. Now, I can say that if I take n to be 4, this would be 100 times of 0.8 raised to power 4. Now, we can calculate this value exactly, but we can see that when the value of N is 3, the quantity of pure alcohol was 51.2 liters. So we can be sure enough that when N would be 4, this value would be definitely less than 50. In fact, if you want to calculate the exact value, this would be 40.96 liters. So we can say that when the value of N would be 4, that is, if this operation is being repeated 4 times, in that case, the concentration will drop below 50%. So the answer would be 4. Okay, so now let us see this question. A milkman has a container which contains pure milk. He takes out 10 liters of milk and replacing it with water. He repeats this process, that is, takes out 10 liters of the solution now, again replacing it with water. The ratio of milk and water is now 49:32. What is the initial quantity of pure milk in the container? So instead of finding the quantity left in the vessel or in the container after 2 operations, we need to find what was the initial quantity of pure liquid in the container. It has been given that the ratio of milk and water after 2 such operations is 49:32. So can we say that the ratio of milk to the total solution would be simply 49/49 plus 32, which would be 49/81. So that means out of total 81 liters of solution, we have 49 liters of milk. So this is nothing but the concentration of the solution. So now if we recall the formula of the amount of liquid left in the vessel after n such operation, which is given by x into 1 minus y by x to the power n. So this is the quantity. So if we want to find the concentration of the liquid in the container, this would be given by 1 minus y by x to the power n, and this concentration for this question is given to be 49/81. So now let us try to simply use the values. So this would be 1 minus the value of y, that is the quantity that is being replaced, is 10. So this would be 10, and the total quantity of the milk in the container x, which we have to find. And there was 2 such operations, so the value of n would be 2, and this would be 49/81. So now if you solve this out, the value of x would be 45 liters. So that means the quantity of pure liquid in the container initially was 45 liters. So in today's video, we have seen the concept of mixtures, and we have also seen some questions based on this topic. But I would request you to practice more questions on this topic, because the more you practice, the more you learn. So I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I'll see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.